Hello viewers, welcome back to class. I'm super excited to have you guys back to class. Don't forget, this is a continuation class. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. And you must ensure that you obey some of our policy here. Don't skip any part of this video for your own benefit, and ensure do not entertain any form of distraction anytime you are set to watch and learn from this platform. Finally, if there be any part in this video you do not understand, when you watch it for the very first time, you have the singular opportunity to replay the video over and over again until you understand it. And that's one of the reasons why this lesson is coming in video format. So guys, let's get to work. On the board, we are still dealing with second order differential equation, and we have solutions to second order equation, and also we are looking at case 2 when f of s is not equal to 0 or f of s is equal to any function. Of course, in our previous lesson, we have explained all of this. Now let's get into the business of applying some of those things that we learned before. Here now, we keep applying principles, rules that we have learned from the previous lesson. Now listen carefully, we are taking the first option or the first category where f of s is a constant function. When f of s is a constant function, it shows that f of s is equal to k, which is constant. And I explained what constant means earlier. Then, in that case, anytime f of s is given as constant, your particular integral is given as equal to y, and y is equal to c. So, when I want to find particular integral, I will just take y and c and work with it. Alright? That's it. So now, this is the first problem that we have on the board. And guys, we are asked to solve this where y over dx squared minus 5dy over dx plus 6y is equal to 24. If you look at this question and look at the problems we were solving in case 1, you discover that every time we were given second order differential equation, the right hand side was always given as 0. But in this case now, we find out that this value is not 0. And this value is 24. And 24 is a constant, which agrees to this sum heading that we have here, right? Now, what must I do to be able to solve this? I know that anytime the right hand side of this equation is not equal to 0, that my general solution must be the sum of complementary function and particular integral. This is it. So if I state that this is my solution, the first thing I must do is that general solution is equivalent to complementary function plus particular integral. This is equation 1. We have designed the promised land while we are still at Egypt. Are we there? So with this concept now, we will now know what to do to move down from Egypt to the promised land. Now we have stated the solution to this question. Now, the question is, how do I get CF, which is the complementary function? And now, how do I get the what? The particular integral. Now, before we have that done, we need to state this question again and type it as what? A particular equation. So let's state the equation. This square y over the s squared minus 5 dy over dx plus 6y is equal to 24. So we will call this equation 2. You can decide to call this one equation 1, then call this one equation 2. Anyone can come first, alright? It's better you state this first, then this follows as equation 2. But let's leave it this way. Now, from equation 2, for us to be able, this is the given equation, right? For us to be able to get the complementary function from here, we need to first of all take this 24 as 0. We need to first of all equate the left hand side to 0. So what we do is to find the complementary function, let the right hand side be equated to 0. Hope you understand what I just did. So all I need to do now is to remove 24 from here and put 0 or replace 24 with 0. Now we will come this page and have this square y over the s squared minus 5 dy over dx plus 6y is equal to 0. Alright, I can call this one equation 3 if I desire to. It's not really, it doesn't matter. Now that we have successfully equated the left hand side of this equation to 0, making the right hand side to be 0, we can now deduce what our auxiliary equation from this equation, because you only deduce auxiliary equation from second order differential equation when the right hand side of the equation is 0. So if this is understood, therefore, all we simply need to do now is what? The auxiliary equation. Guys, we know we have solved this over and over again, so I don't need to be putting the statement again, all right? So that we can meet up with time. But you can do that anytime you're writing exams, okay? So the next option now is to deduce the auxiliary equation. And from the understanding that we had before in our previous lesson, we said that d squared y over dx squared is equal to m squared, dy over dx is equal to m, and y is equivalent to 1. Are we there? So anytime you want to deduce the complement to the auxiliary equation from the given equation, you replace this with this guy, replace this guy with this guy, and replace this guy with this guy. Therefore, if you do that, everything here has turned to m squared. Then minus 5 multiplied by m, then 6 multiplied by 1, and 6 multiplied by 1 is 6, equal to 0. This has given us equation 4. We now need to what? Obtain the value of m here. Because what we have now is quadratic equation, and we know how quadratic equations are solved. In our previous lessons, we were using factorization method, except in cases where factorization could not solve the problem, right? So in this case now, let's also adopt factorization method. Like I explained, you can use any method of your choice. Any method of your choice. It is accepted. Okay? Now, if we are using factorization method, I'm going to be very fast because we have done this over and over again. This would have given us 6 m squared, right? So this would have given us m squared. The factors of 6 that will give us 5 would have been 3 and what? 2. And for me to have minus 5, I need to have minus 3m minus 2m plus 6 to have minus 5m. And when I multiply minus 3m by minus 2m, I'm going to have positive 6m. This is equal to 0. So if you do not understand what I just did here, please go back to a session when we were looking at the case where f of s is equal to 0. We saw thousands of problems there where we explained this aspect of quadratic equation very, very well. Are you there? Okay. But I believe you understand what I've just done. So between the first two terms, you will tag them and also group the last two terms. Now between the first two terms, what is common here is m. Now when I divide m squared by m, I will have m. When I divide minus 3m by m, I'm going to have minus 3. Then put down this minus at the middle. Between the last two terms, I have m here, but there's no m here. That means m is not common. Then this is 6, this is 2, and 2 is a factor of 6. That means 2 is common. Then put down to open bracket. Then repeat the same thing you have in the first bracket. This is for the sake of time. Alright? That's it. Now that we have successfully gotten this, the next thing we are quickly going to do is to collate the multiplication factors. And what are multiplication factors? Multiplication factors are factors that are outside the brackets. Are you there? So the first factor outside the bracket here is m, and the second factor outside the bracket is minus 2. This will give us 1 bracket. Then we can now pick one of the equal brackets. M minus 3. Everything equal to 0. And like we have explained before, we said that for the product of two factors or two functions to be 0, it is either the first is equal to 0 or the second is equal to 0. One of the factors must be 0. But we do not actually know the one that is 0, so we are going to assume it's either the first or the second. This is when probability comes in. Are you there? So we therefore have m, it is either m minus 2 equal to 0 or m minus 3 equal to 0 for the product of these two functions to be 0. Now, if this is understood, all I need to do is to find m or make m the subject of formula. Then we have this as m. As minus 2 crosses from left to right, it automatically becomes positive 2. Or, now as negative 3 also crosses from left to right, if we have positive 3. Therefore, m is equal to 2 or 3. Now that you have the values of m, listen carefully. This is where intellectuality comes in, or technicalities. You now need to understand what are the rules that you have. A real? Yes. Different? Yes. That's it. So we have real and different rules. They are real, but they are not the same value. That means they are different. Now, what is the general solution for a second order differential equation that have real and different rules? The solution is given as complementary function is equal to y is equal to a e mx m1x plus b m2x. Hope you remember. This is where it comes in. So, like I explained earlier, you will be the person to determine the equation you will use after you have successfully obtained the value for n. You don't have to go with this into the examination hall. So that's why you need to have them here. Are you there? You need to have them here. Now, all I need to do is that my complementary function, I can remove y now. Because we are used to y. That's why I just decided to introduce y. Because your complementary function is exactly the same thing as y. Are you there? Now, we then have a, the first value of m is what? 2. We have x plus b, and the second value of m is 3. This is the complementary function, which is not different from case 1 that we have looked at. So the difference between this and the first case is what we are going to do now. So now you can still state it here to find the particular integral. Alright? Now to find the particular integral, all you just need to do is to remember this standard. To find particular integral, all you need to do is that particular integral is equal to y and y is equal to c. So I only need y is equal to c. This I will call this one small letter equation A. This is what I need to get my particular integral. Of course, just the same way we said CF is equal to y, then y is equal to this. The same thing we just did then. I want to ignore this first. Once I get y, I know that my particular integral is equivalent to y. So let me first of all find what y is. So the interest here is to know what is the value of c. C must be a true value. It can be 4, it can be 5, it can be negative value, it can be positive value. And how do we get that done? All we just need to do now is, now that we have gotten a particular integral equation, well, we need to differentiate this equation 2 times. Now, if we differentiate y with respect to x, now this is a constant because it is not carrying x. And anytime you differentiate a constant, a function without x, you have 0. This is 0. And also, when you differentiate the second time, you also have 0. When you differentiate 0, you have 0. So now, having differentiated this particular integral function, all you need to do is to substitute this, and this guy into the given equation. So you now come to equation 2, that we label equation 2, which is the given equation, and impute these 3 values to be able to obtain the value of c. This is how it is. Okay, if this is understood, guys, what do we do here? All we just need to do now is to come here. The value of this first term is 0. We are substituting into equation 2. Then minus 5 multiplied by dy over dx is also 0. Then plus 6 multiplied by y. And what is y? Y is c. Then the right hand side is 24. We just substituted those 3 equations now, or those 3 results here, into the given equation. And the given equation, based on what we have here, we labeled the given equation as equation 2. So you can simply state, substituting this, and this into equation 2. You can make the statement here. Are you there? Okay. So if this is understood, this would have given us 0. 5 multiplied by 0 is 0, plus 6 multiplied by c is 60 equal to 24. And from here, all we need to do is to add everything up. We have 24. And when we find c, understand that we are looking for the value of c. So we are going to divide both sides by 6. And then we have c equal to 24 divided by 6. And this will have given us what? 4. This is the value of c. Now that we have gotten the value of c, the next thing we are quickly going to do is to come to the particular integral. Therefore, the particular integral is equal to y, and y is equal to c. So your particular integral is equal to c, which is equal to 4. It's as simple as this. So you have gotten the particular integral. Particular integral equal to y, and y equal to c. That is to say, particular integral is equal to c. And what is c? C is 4. So in this question now, the particular integral is 4. Now, what will now be the general solution to this whole equation? The general solution to this whole equation would have been what? Our equation 1. All we just need to do now is to state equation 1, then impute the values, or just impute the values. So from equation 1, we have that y is equal to complementary function plus particular integral. Now we have y is equal to that. What is our complementary function? Look at the results for complementary function here. Then you have a exponential 2x plus b exponential 3x plus 4 particular integral. This is the answer to this aspect of second order differential equation when f of x is constant. Now we are going to solve one more problem for more emphasis and for better understanding. We want to clarify and clear some of your doubts so that you will be able to gain mastery over this aspect of second order differential equation. Don't forget that when you know principles, you suddenly become a principal, and when you know boundary conditions, you will not overstep your boundaries. Don't forget, at this point, if you have not subscribed to this YouTube channel, do consider subscribing to this YouTube channel and ensure that you turn on the post notification bell so that anytime we upload mind blowing content, even while you are asleep, you will be notified. Alright, now also don't forget to like this video, share this video, and make your necessary comment. Now let's get to work as we solve question. Now we are asked to solve d square y over the x square minus the y over the x minus 2y is equal to 6. First is to look at the right hand side of the equation. Of course, we have seen that this is second order differential equation. Then look at the right hand side, and we find out that the right hand side is not equal to 0, but a constant. I mean, you are still following this same method. What do you do here? The first thing you do is to put down your solution. Then you can state the equation if you want to, or you can from here just label it as equation 1. But let's state it over the x squared minus dy over the x minus 2y is equal to 6. Then this is equation 1. Now that we have identified that the right hand side of this equation is not 0, that means this equation contains both complementary function and particular integral. That is to say, the final solution will be the sum of complementary function and particular integral. Then let's take it ahead of time. We therefore have that general solution y is equal to complementary function plus particular integral. This is our equation 2. So this is where we are going. Now, how do we now get the complementary function? And like I explained, to get the complementary function, all you need to do is to take the right hand side of the given equation as 0. Equate f of x here as 0. So I just to find the complementary function, let the right hand side be equal to 0. So just equate the right hand side of f of x as 0. Therefore, we are going to have this equation as d squared y over dx squared minus dy over dx minus 2y is equal to 0. You can call this now equation 3. Now, from the current equation 3 that we have, we know that anytime second order differential equation is equated to 0, we can deduce the auxiliary equation. It is the auxiliary equation that will help us to provide solution to that aspect of the equation. So the next thing now is to what? State the or convert this second order differential equation to its equivalent auxiliary equation. And how do we have that done? The auxiliary equation, we replace this by m squared. We replace this guy by m. Then we replace y by 1. So 2 multiplied by 1, we have 2. And this is equivalent to 0. We can call this equation 4, which happens to be the auxiliary equation. Now, from the current equation 4, we discover that equation 4 is a quadratic equation, right? So we can use any method of our choice to solve this equation. Are we there? Now, if this is understood, all we simply need to do here is to use factorization method if possible. I taught you guys in our previous lesson how to check whether a particular quadratic equation you are given is factorizable. I gave us 2 methods of having that done, right? You can use formula, which I stated in our previous lesson, and we can use what we have. Now, me as a person, I already know that this equation is factorizable. All right, 2 multiplied by 1 is 2, and 2 minus 1 is 1, right? So all I need to do here is to have this as m squared minus 2m plus m minus 2 is equal to 0. Understand that when you multiply this, you are giving minus 2m squared, right? Yeah. When you multiply this guy to this guy, you have minus 2m squared. And I explained that for the factors of 2 numbers to give you a negative result, one of the factors must be negative. So it is either 2 is negative or 1 is negative. Because 1m multiplied by 2m will give us 2m squared. So for us to have minus m at the middle here, minus 1 here, it shows that the highest value is supposed to go with the negative sign. That's why I just go through with this. But with the methods I taught you before, you can ascertain or check out how I obtain these values. Are you here? Okay, so we will now group the first 2 terms and also group the last 2 terms. Now between the first 2 terms, what is common is just m, right? Now if m squared is divided by m, we have m. And if minus 2m is divided by m, we have minus 2. then plus. This is m and this is minus 2. And we see that nothing is actually common. And understand that anytime you are factorizing an expression and nothing is common, 1 is common. So put down 1, then repeat everything that you have. 1 minus 2 is equal to 0. So when you multiply this by 1, you get back to this. Then the next thing we do is to quickly collate the multiplication factor as one bracket. Now, the first multiplication factor here is m, which is the number outside the bracket. Then the other is plus 1. Then we now have one of the given or equal brackets. That's pick one of the equal brackets, then collate the multiplication factors, which are the factors that are outside the brackets. Are you there? Okay, now that we have two brackets multiplying each other and the result is equal to 0, we know that in mathematics, for the product of two functions or two factors to be 0, one of the factors must be 0. But we are not sure of the factor that is equal to 0. And that's the reason why we are going to assume either the first is equal to 0 or the second function is equal to 0. Hope this is understood. These are mathematical laws. When you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. The words of the wise masters. Okay, now we have m plus 1 equal to 0 or m minus 2 equal to 0. This is it. Then also, I will now make m the square formula when plus 1 crosses from left to right, it automatically becomes minus 1, which will have 0 minus 1. And 0 minus 1 is minus 1. Or when minus 2 crosses from the left hand side to the right hand side, it becomes plus 2. Then finally, we now have m is equal to minus 1 or positive 2. Like I explained before, I said anyone can come first. You can decide to take 2 first or 1 first. With what we have here now, we therefore have that m1 is equal to minus 1 and m2 is equal to 2. Why are we separating it? Because we have real but different roots. So therefore, since they are real and are different, then we'll group them. Then we'll take m1 as the first value, then take m2 as the second value. Now, when you have two m's, which equation do you use? You make use of real and different roots. And what's that equation? You recall that your complementary function is equal to y equal to a exponent m1 of x plus b exponent m2 of x. Now from here we have that the complementary function is equal to a. Now when we substitute minus 1 here, we are going to have this as minus 1x, which is same thing as minus x, then plus b, this will have given us 2x. This is the complementary function. It's as simple as this. Now guys, now that we have obtained the complementary function, what next? The next option is for us to obtain the particular integral. And how do we obtain the particular integral? We come here and to find the particular integral. Recall that particular integral is equal to y. And what is y? When the right hand side of any given second order differential equation is constant, is c. So you just equate it to c. Alright? So if y is equal to c, when we differentiate y with respect to x, we have 0. And when we differentiate 0 with respect to x, we will have 0. So like I said, once you are able to get the particular integral y, you need to now differentiate that y 2 different times. Why are you differentiating? You simply differentiate because you need those values to be substituted into the given equation so that you will be able to find the value of c. Are you there? So to obtain this constant, you must substitute back into the given equation. And that's the reason why you need to differentiate first and second time so that you can substitute for this first guy, substitute for the second guy, and then substitute for y, which you already obtained. Now that we have gotten that, all we just need to do is to come to equation 1 and impute those values. Now, when we substitute into equation 1, the first value there is 0, minus 0, then minus 2 multiplied by what is y? Y is c. Then equal to the right hand side of the equation is 6. Guys, this thing is very simple. It's just an understanding that you need. Understanding, that's what you need. Now, if this is understood, everything here is automatically 0, so we are going to have this as minus 2c is equal to c. Now, understand that we are looking for the value of c. So what do? We will divide both sides by minus 2. That would have given us c is equal to 6 all over minus 2. and C would have given us -3. Now that we have obtained C, it therefore shows that the particular integral is equal to y is equal to C, like we said, and is equal to -3. C now, particular integral equal to y equal to C, and C equal to 24. It therefore shows that particular integral is equal to -3. That's it. What do you do now that you have gotten the complementary function and you have gotten the particular integral, like I explained earlier? Then we are already at the promised land. All we need to do now is to add up the two values, and we are done. So we just recall equation 2, where we have that general solution is equal to the complementary function plus the particular integral. And now we know that the complementary function is this value, so we put it there. This would have given us a exponent minus x plus b exponent 2x plus a minus 3. Don't forget that the particular integral is -3. So automatically everything here would have been -3. Minus multiplied by plus is minus. So this is the final answer to this question. So guys, like I explained earlier, this aspect of mathematics is simple. In fact, there is no mathematics that is hard if you know the principles. Seek to understand the principles, because that is what will make you expert. And to be able to maintain your boundary conditions, then you must know boundary conditions. These are the keys that will always help you to gain mastery over any aspect of your academics. In fact, every aspect of your academics to understand the principle. That's why the Bible says, wisdom is the get wisdom, get understanding. With all guys, we love you. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell. More exciting videos. Like this video, share this video, and ensure make your necessary comment at the comment section below. Now, guys, you can check the description below where you will find the link to the next lesson. See you guys in the next.